simplifying. This is from the worksheet number 2. We're going to be looking at number 6 to begin with. I chose this one because it had some powers to the fourth that initially you might look at and think, I don't even have any formulas that even look like that. So, what I wanted to remind you was that secant squared x squared altogether is in fact a square itself. So something to the fourth power is just something originally that was squared again. So when I look back at this problem up top, I see at the top you have a fourth power of secant and a 1. That's two different squares. So this does still qualify to be the difference of squares, except when we pull it apart, I'm going to have secant squareds left over rather than just secant. So if we look at how that works out, if you factor the top, so we're going to notice the difference of squares in the top of the fraction. We take this, we're going to separate that, knowing this part here. If we know that, then we can separate it into this part. Remember, it has the square root of the first thing in the first position. It has the square root of the second one in the second position, and then it has 1 minus and 1 plus. Alright, second thing we're going to do is we look at the bottom. We think, well, how can I change the bottom? Obviously, none of them look anything like the top, so hopefully something's going to work out. If we look at the bottom, we see that, well, they do have a common factor of secant squared. So we're going to take that and we're going to factor that secant squared out, and we're going to look at it and see maybe something will cancel. And sure enough, when we look at this, you now see that you have a secant. When you pull the secant squared out of the bottom, you're left with a secant squared x plus 1, and that's the same thing that was on the top. That allows me to cancel here, and when I look at what's left over, hopefully at this point you recognize that the secant squared x minus 1 is one of your Pythagorean identities, okay? Or at least it's a version of it, right? And so we take that and we look at our Pythagorean identities. We'll make a substitution that's actually tangent squared, okay? And tangent squared x over secant squared x, the way that we change this one is we go everything to sine and cosine, and we're going to make that little substitution, and you have this. So we change tangent squared to sine squared over cosine squared. We change secant squared to 1 over cosine squared. We keep the top the same, like we do here, and we take the bottom fraction, we're going to flip it over, and then the cosines cancel, and I'm left with, well, just sine squared. And that's the end of number 6. Not really long, but at first glance you might freak out and think, oh, I can't do this because it's got a secant to the fourth power. Okay, but if you ever see that, then you want to think of, oh, maybe this is something squared. So it still fits the difference of squares pattern.